So in today's video, we're going to be reviewing the past topics which we have been studying so far in mathematics, and we're going to take national examination questions, and we're going to be answering them, and you're going to see how you can tackle such questions in your exam. So make sure you check out our channel and check out our playlist, only the playlist to other tutorials, to other course tutorials we've done so far in the channel, and you can see by yourself what we have done so far, and I'll try as much as I can to explain everything in this video. So yeah, these are the questions we have, and we're going to be dealing with Cameroon GC. So these are the questions here. We're going to start from 2011 heading to 2021, and if you have any questions below the CS or any questions of national exam questions from your country, we will happy to get those questions from you. So far in mathematics, we have covered quadratic equation, we have covered logarithm and indices. So these are the topics which we have covered so far: quadratics and quadratic equation, logarithm and indices, or initial logarithm as you may call it, partial fractioning, and inequalities. So the first question, which is from 2019, which we're going to tackle: find the real values of x for which 3 raised to the power 2x plus 1 minus 12x into 3x plus 9 equals to 0. So this is the equation here which we're dealing here. So we're asked to find the real values of x for which this equation is equal to 0. So the first thing when you see such questions is to list out the laws of logarithm, indices and logarithm. But however, this is minus, you're not seeing a logarithm sign here. This is mainly indices, because this topic is divided into two parts: logarithm and indices, and the laws are almost the same, but there are some differences as well. So this is the question, which is from June 2011. So June 2011, question 1. To be precise, Cameroon GC, because we have the London GC. Okay, so let me just list some laws of indices and precisely the one we're going to be using here. So let's start with this. Let's say we have 4 times 8 is equals to 32. Okay, and we know that 4 is equals to 2 to the power 2 times 2 to the power 3, because you multiply 2 by itself 3 times to get the value of 8. And again, I'm not going to dive deep into much laws and basic laws of arithmetic. Okay, I will assume that you guys are smart enough and know this. I'm just going to take into consideration the laws of indices. So this is equals to this, and now 32, try and divide 32 by 2 by 12 until when you get a value of 1. So let's say we have 32 divided by 2. This is equal to 16. This is already 1 time. Divided by 2. This is equal to 8. This is 2 times. Divided by 2 equals to 4. We have 1, 2, 3. Now this divided by 2, divided by 2 is equal to 2. Or I guess we'll get up to 1. Again, 2 divided by 2 is equal to 1. How many times do we divide 32 by the number 2 before getting number 1? This is 1, 2, 3, 4, 5 times. So this tells us that 2 to the raised to the power of 5 is equal to 32. And from the first law of indices, I don't know, respect to your textbooks might be different. So here, 2 raised to the power 2 times 2 raised to the power 3, provided the bases are the same. Now in this case here, the bases were not the same. You see, we had the base of 4 and base of 8, or raised to the power of 1. So we made them have equal bases. And then we have this value of 2 to the 2 plus 3 equals to 2 to the 5. Now, this is for multiplication. In case of division, the operation sign will have changed to a negative. So same as 8 divided by 4, which equals to 2, will have been 2 to the raised to the power of 3 divided by 2 raised to the power of 2 will have been equals to 2 raised to the power of 3 minus 2 equals 2 raised to the power of 1, which is equal to 2. Okay, so now we're ready to tackle this our first question. So the solution, as we had for this problem, we're going to have 3 to the 2 of x times 3. Okay, times 3 minus 12 into the 3 of x plus 9 equal to 0. Now, you notice something, that all divisible by 3. All these numbers are divisible by 3. So we do the division by 3. This will imply that we have 3 to the x all squared. I'll skip a step here for simplification to reduce the amount of time we're going to take for this video to make it shorter. Here, when you have this number here, 3 to the 2 of x is same as 3 to the x all squared. Remember, we are in exponential power, is not just normal multiplication. So the 3 is gone, minus 4 to the 3 of x plus 3 equals to 0. Okay, now this now resembles like looks like a quadratic equation. And now you see our quadratic equation is very that plays a lot of meaning for mathematics topics, even trigonometry and differentiation. You always find them. Okay, so solving this particular quadratic equation like this is not really that easy. The first step we're going to do is to look for any letter and we assign it to our variable here, which in this case is 3 to the x, because it's the same thing as a x squared plus b x plus c equals to 0, where a is equals to 1, and this is x 3 to the 2 raised to the power of x minus 4, b equals to negative 4 times x again, which is 3 raised to the power of x. Okay, so let's say the arbitrary letter could be e, could be p. It's already choice me. I'll choose e. So we have e squared minus 3e, minus 4e plus 3 equals to 0. Now, here we are with the quadratic equation. There are different methods of solving quadratic equation, and in my playlist I spoke of 3 different methods, which is we have the formula method, the factorization method, and we also have completing the square method. This problem can easily be solved with the factorization method, and that's the method I will always recommend you all to use, except it's not factorizable. In that case, you use a formula. The formula will always be simplest. Unless you're asked to use completing the square, use completing the square. Okay, so now in factorization, the rule is this. We have these two numbers. This is our a, this is our c, and this is our b. We have to look at two numbers. Okay, two numbers that when you multiply will give you AC, which is the product of coefficient of a and coefficient of c. And when you add those two numbers, we give you b, and b in this case is negative 4. So to begin with, what are the possible numbers that could give negative 4? We have negative 2 and negative 2. So that is negative 2 plus negative 2 gives us negative 4. We also have a 1 minus a 5, which gives us negative 4. However, to limit the range of numbers which you're going to use for a recurrence, you should also take this into consideration that we are not just looking numbers to satisfy one condition, to satisfy two. So here it's an AND situation. Two need to be satisfied. So already taking a look at numbers like 2 and 4, sorry, 2, negative 2 and negative 2, 1 and negative 5, they're already not satisfying the second rule or the first rule, which will depend on you, that is giving us a product of A and C. So those two numbers are already out of range. So when doing this, make sure the numbers should also be able to fall in this condition. So the number we will choose to work with are negative 1 and negative 3. -1 plus -3 give you -4, and multiplying the two numbers, negative sign will cancel, we end up having 3. So when we proceed, this will imply that we are going to have e squared minus e. Now, at this stage, your choice. You could put -3e. It's all your choice. The answers will still be the same. So for the little challenge, you could try that and put -3e. We'll see at the end of the day if our answers are the same. If our answers are the same, please give me a thumbs up for the video and we'll continue solving. So -3e plus 3 equals to 0. So now the second step here is to separate them into 2. For the first 2, you keep them aside. Second 2, keep them aside. Factorize them. Okay. Well, as I'm taking much of this time to explain this already quadratic formulas and quadratic method of solving quadratic equation, in the next questions which require quadratics, I hope you understand that to make the video shorter, I won't have to take all this time in doing this. Okay. So yeah, when we take here the common, what is common here is e. Okay, e into e minus 1, and here what is common is 3. Okay, so now 3 is common here, but however, if you put the negative, if you put the 3 here plus 3, like for example, let's have this for a try, plus 3 into e. Now see a problem? E here got to be multiplied by a negative number, and if it's to be multiplied by a negative number, now again, this is another thing I would like to let you know. When you're factorizing into us, make sure as much as you can that what is in your bracket here should be the same, because they all end up forming one factor. Okay, they should be the same. So we have e. This already was just for trial, so we're going to have e into e minus 1 minus 3 into e minus 1. And again, give a lot of priority to the first one. Okay, give a lot of priority to it. Now, this implies that e is going to be equal to this number, which is 1, or e is going to be equal to 3. Because at the end of the day, we're going to have these two factors, e of minus 3 and e of minus 1. Now remember, they are equal to 0. So you have to equate it to 0. Now, there is a problem. We didn't start solving this problem with e. We started with something which will use it as a substitute for e. Okay? So, e is equal to 3 to the x. Okay, e is equal to 3 to the x. This implies that 3 to the x is equal to 1 in the first case. Now, there is another law again, and this is that every number raised to the power of 0 is equal to 1. And again, we want to try and make sure the bases will be the same, or ideally the base 3. So, this will imply that 3 to the x is equal to 3 raised to the power of 0. This implies x is equal to 1. And for the other case, x is equal to 1 because we have 3, right? 3 raised to the power of 1 is 3. So, this is all for the first part of this question.